So good morning everyone. So in today's session, we try to cover the operating system remaining question. So these are the basic question. We cover most of the hard and this medium level question in the earlier session. And this is a session basically about what are the fundamentals and what is the logical and basic question we have to discover. So first question that comes in our mind or that's anyone can answer. That is, what do you mean by operating system and what is the basic function? So like, how can you explain this operating system in the layman language and what does it mean? So first of all, the OS, the operating system is basically a software. Okay, so it is a software program that manage or handle all the resources of the computer and the hardware. So we can understand this is like this is our computer, okay, and this is our hardware. This is the our hardware. Okay. So, so, so like our computer want to talk with the hardware and manage all the resources. In that case, OS play an important role. Like OS can handle all the resources of the computer and the hardware and the software. Okay, hardware and software. The first OS was introduced in 1915, and an OS is responsible, known as GMO, and that time it is known as GMO. And OS is responsible for the managing, handling, coordination, overall activity of sharing the computer resources, or it act as an intermediary among the user of a computer. So like user of computer to the computer hardware. So it act as a bridge. Okay. And when we're talking about the function of operating system, so there are many functions. So there are many functions of the operating system. Some of the important functions of operating system are as follows. So first of all, the memory management, memory and process management. So the memory management, all the like disk spacing, process scheduling, all these things done by this operating system. Okay. Then we move to the providing user interface, like providing user interface to the user. So it provide a user interface through which we can give a command and handle anything inside our computer. Okay. File management and device management is also done by the operating system. Scheduling the resources and the job are done by the operating system. So like we have three different process, and like these like processor like process have to done correctly. So in that case, operating system work like sometime it use queue data structure like priority queue or like managing all the things. Okay, all the error detection and security and all these things. So these are the function of the operating system. So it is basically a system software program that manage handle all the resource like handle all the resources of the computer, such as hardware and the software. Okay. So what second question is, what is the main purpose of OS and what are the different type of OS? Okay. The main purpose of the OS, we know that the main purpose of OS is to execute user program and make it easier for the user to understand. First of all, make like a user like a main purpose of operating system is to execute user program and make it easier for a user to understand and interact with computer as well as run the application. So it is specially designed to ensure that it is specially designed to ensure that a computer program perform better by managing all the computational activity, and it also manage the computer memory. Okay. So that is so like we are talking about. So like what are the next features? So it manage the computer memory, process operations for of all the hardware and software. So these are things that are managed by our operating system. Again, what is the type of operating system? So first of all, the different type of operating system are the batch operating system. Okay, that is payroll system, transaction process. This is a batch operating system. Then multi-program operating system, that is like multi-program. So these are the Windows, Unix, all this Linux, everything are multi. Then time sharing operating system are the multics. distributed operating system as a locus. Okay, a real time operating system is a POS we are using in like banking, all these things. So these are the different type of operating system and their like and their purposes. Okay, so and let's see what is an operating system's importance. So like this is I'm explaining the same. I'm explaining or same the question. You have to like by heart this answer. Okay. So operating system is the most essential and vital part of the computer without which it is considered useless, and it enable the interface and act like a link of interaction between computer software and installed in the computer software that are installed in the operating system and the user. It also helps to communicate with the hardware and also maintain the balance among hardware and the CPUs. Okay. So it also provide a service to user and the platform of the program to run on it, and it perform all the common tasks. It will perform all the common task that application require. So this is like a primary definition. This is primary definition of what is an importance operating system. So it act as a vital role in the computer. Okay, and it is considered like without, if we can't imagine any computer without an operating system. So it link the interaction between computer software and the install app, computer software and the install app in the operating system. And it also helps like communicate and also maintain the balance among hardware and CPUs, and it provide a user to, like services to user and the platform for the program to run on it and perform all the common task applications that are required. So now the third question is, what are the benefit of the multiprocessor system? So like as the name says, multiprocessor. So like we have multiple processing units. A multiprocessor system is a type of system that include two or more CPUs. Okay, as the whenever you use like multi-processor, so multiple processors, so in like two or more CPUs. Okay, so it involves the processing of different computer program at the same different computer program at the same time, mostly by a computer system with two or more CPUs that are sharing the single memory. Okay, this is our computer and these are the two application. These application, this is our computer and these are the like two applications that are running on like a running. Okay, like computer different programs, so like same time. So in that computer system where like it have a two CPU. Okay, one CPU and CPU. These are like a multiprocessor system. Okay, so like a CPU setting, so this task is given to this CPU and this task is given to this CPU. So the computer system with the two or more processors that are sharing a single memory and having the single memory. So how this two system runs? So these are done by the multiprocessor system. What is the benefit of using the multiprocessor system? So the first benefit is such systems are widely used nowadays to improve the performance in a system that are running multiple programs concurrently. Okay, these systems are very much important because we see that multiple program are running concurrently. Okay, by increasing the number of processor, a greater number of tasks can be completed in a unit time. So if we increase the number of like processor, the multiple tasks like three tasks can be completed at a time. One also get a considerable increase in throughput, and it is cost effective as well. And processors share the same memory, so it simply improves the reliability of the computer system. So these are the benefit of the multiprocessor. Okay. These are the basic question. Now move to the intermediate question. That is, what is the RAID structure in OS and what are the different level of the RAID configuration? So RAID, whenever we heard the like word RAID, what does it mean? Like RAID stands for the redundant array of independent disks. redundant array of independent disks. So it is a method to use, like it is used to store data on a multiple hard disks. Okay. So like it is read a system, like it is like a method. What do we call it? It is a method. Okay. So it is a method to store data on a multiple disk. So store the in a multiple disk hard disk. Therefore, it is considered as a data storage virtualization technology that combine multiple data storage and the virtualization technique that combine multiple hard disk, and it simply balance the data protection, and it simply balance the data protection. And data protection system performance, storage space, all this data protection system storage, all this thing. And it is also used to improve the overall performance and reliability of data storage. So so first of all, RAID is a method. So RAID is a method. So like we can say RAID is a method that store the multiple the stored data on a multiple hard disk. So these are data stored on multiple hard disk, and it is considered a data storage virtualization, and it combines multiple hard disks. So as we see that it combines the multiple hard disk. Okay, so it combines multiple hard disk. So it's simply used for the data protection. Okay, reliability for the storage. It also increase the storage capacity. We have 1 GB. So in 1 GB on it, so totally 3 GB we have. So it increases the capacity, storage capacity of the system, and the main purpose of it is to achieve the redundancy, like a data redundancy, and reduce the data loss. Okay. So different type of RAID level we have. So the different type of RAID level we have, that is nowadays RAID is available in the various scheme. Okay, various scheme. The RAID level as given below. So if we have RAID 0, so this means that no redundant stripping. So this level is used to increase the performance of the server. So different RAID level have like different purpose. So if I said a RAID 0, so that is non-redundant strip, and it is non-redundant strip, and this level is used to increase the performance of the server. Okay. Now move to the next part, that is RAID 1. So like a mirror and duplexing. So this level is known as a disk mirroring, and is considered as the simplest way to implement the fault tolerance. Okay, mirror and duplexing thing. And RAID 2 is a memory style error detecting code, like a so RAID 2 stands for the memory style error correcting codes. Okay, so this level generally use dedicated Hamming coding code parity, a linear form of code correction, like a linear form of error correction code. Okay, move to the third RAID, that is bit interleaved parity. So this level require a dedicated parity. Okay, dedicated parity disk drive to store the parity information. Block lived, bit lived is third. A block lived parity. So this level is similar to like a block RAID 5, but the one difference is that this level confirm all the parity data on a single drive. And RAID 5 is a block leave distributed parity. So this level provides far better performance than the disk mirroring and the fault tolerance things. Okay, and the RAID 6, that is P plus Q redundancy. So this level generally provide a fault tolerance for 2 drive failures. You understand all this thing? So RAID 0 means that it is a non-redundant stripping, where it is used to increase the performance of the server, and and RAID 1 is like a mirroring and a duplexing thing. So this level of the disk, it is considered as one of the simplest fault tolerance things. Okay, when we move to the two part, that is memory style error criteria. So in this dedicated Hamming code parity is there, we have to check an error detection. And third is a bit bit interleave parity, then have the block interleave parity and the block distributed parity, and the P plus Q redundancy. Okay. So these are the these are different. So what whenever someone asks what is RAID, so you can say RAID stand for the RAID stand for the redundant array of independent disk, and it is a method to store the data in a multiple disk considered as a data storage virtualization technology that combine the multiple disk to simplify the data protection, performance, and storage space, all this thing, and it also improve the overall performance of the reliability of the data. And okay, let's move to the next part, and that is what is GUI. GUI. So like GUI is the simple one, that is graphical user interface. So graphical user interface, and it basically a type of user interface that allow user to use graphic to interact with the OS. As the name suggested, you can explain to any of the interview that what is the difference and what is the meaning. So graphical user interface, right? But it is basically a type of interface. So in this, we can say that type of interface that allow user to use the graphic to interact with the OS. And GUI is created because it is more user friendly, less complex, and easier to understand rather than a command line interface. So we understand in the last three session in the Linux, in which we understand there are two type of by two type we can interact with this in this our operating system. First one is CLI, that is command line interface, and the second one is that graphical user interface. So its main goal is to increase the efficiency and ease of the users. Okay, instead of having to memorize the command, like a user can just click the button and simply execute the procedure. For example, GUI include like Microsoft Windows, Mac OS, Apple iOS, etc. Okay, let's move to the next part. What is the pipe and when it is used? The pipe is generally a connection between two or more processes. So this is the one process P1, and this is another process, that is P2. So this is called pipe. So like pipe is generally a connection among the two or more processes that are interrelated to each other. So and it is a mechanism that is used for and this is the mechanism of pipe, connection between connection between the process, and this mechanism is used for the inter-process communication using the message passing. Okay, one can easily send the information such as output of one program. So in the output of one program to another program processes are using as a pipe. Okay, by the pipe we can share this thing. Okay, so it can use it can be used when two processor process want to communicate one way. Okay, so inter-process communication. So this process want to communicate with this process in one way. So in that case, we use pipe. So what are the different kind of operation that are possible in semaphores? So there are basically two atomic operations that are possible. There are two atomic operations that are possible. That is first is kind of operation that are possible. So wait and signal. So we have two process, and these are the ready queue. So the two things that semaphore have, first of all, we give this process a signal to go inside. Okay, and I give a wait signal to this one to wait. The two atomic operation that I use in semaphore. Another one is that what is the bootstrap programming in the OS? So bootstrap programming. So it is generally a program that initializes the OS during the startup. So bootstrap, it stands for so it is a program that was start or initialize the OS this program generally that initialize the OS during the startup time. Okay, the first code that is executed whenever the computer startup. Okay, the first code that is executed whenever the computer started. The OS is loaded through the bootstrapping process or the program commonly known as booting. Okay, the overall OS only depend on the bootstrap program to perform and work correctly, and it is fully stored in the boot block at the fixed location in the disk. Okay, so all the OS, we can say that overall the OS depend on the bootstrap program to perform and work correctly, and it is fully stored in a boot block and a fixed location of the disk. So it is locate the kernel and load it into the main memory after which the program starts their execution. Okay, then we can say that is the first. This is the first program that run in our OS. Like, so next question is, what is demand paging? Explain demand paging. So a demand paging is a method that load demand paging means demand, you are demanding for page. So this is like a demand or page. So we are demanding for a page. So this method that load the page in like this method is like this method that load the page in memory on demand. So this is called demand paging, and this method is usually used for the virtual memory. Okay, virtual memory. So in this the page is only brought when memory into the memory when the location on a particular page is referred during execution. Okay, the following steps are that follows. So first of all, try to attempt attempt to access that page. If page is valid or in that memory, then it continue processing the instruction as normal. But if page is invalid, then page fault trap occur. Okay. So check if a memory reference to a valid check a memory reference is a valid reference to a memory on a secondary memory. If not, and the process is terminated. So illegal memory access. Otherwise, we have to page in that the required page. Okay. So and the schedule disk operation to read that desired page in main memory and restart the instruction that was interrupted by the operating system trap. Okay. So first of all, we try to access that page. If memory is available, we continue our process and instruction in a normal way. Okay. And if page is not there, so then like page invalid and we try to access it and page fault occur. Okay. And we have to check the memory reference which is valid to the location in the secondary memory. If it is not the process, it terminated, like it got terminated, that is called illegal memory access. Otherwise, we have to page in that page required. Okay. Now then we have to like schedule the disk to read the desired page into the memory and restart the instruction, and that was interrupted by the operating system trap. Okay. What is what is R what do you mean by like RTOS? So as the name suggested, RTOS stands for real time operating system. So real time operating system is the operating system that is used for the real time application. That is for those where data processing should be done in the fixed or same measure of the time. So it perform much better task than we like needed to execute within the short time. So so we expecting in the real time operating system is like a kind of real time application where we use application to process the data on the fixed and a small measure of times. Okay, and perform much better than needed and executed in the short time. So it also take care. So it also take care of the execution, monitoring all these things. So it also take care of the execution, monitoring, all the controlling process, and it also occupy less memory and consume fewer resources. Okay. So types of the types of real-time operating systems that are like hard real-time operating system, firm real-time operating system, and soft real-time operating system. Like RTS in the air traffic, anti-lock brake system, hard pacemaker are the like these are the real-time operating system. Now we have to see what do you mean by process synchronization. The process synchronization is basically a way to coordinate the process. So this is the process. So like uh, so this is P1. Okay, this is P2. Okay, process synchronization way to coordinate with the process that use shared resources. Okay, shared resources of the data. So it's shared the same resources or the data. Okay, and it is very essential to ensure that synchronized execution of the cooperating uh, like we can say process synchronization basically a way to coordinate the process that use shared like resources and data, and it is essential to ensure that synchronization and execution cooperating process so that maintain the data consistency. The main purpose is to share the resources without any interface using a mutual exclusion. Okay, there are two type of process synchronization, like independent process and the cooperative process. These are the different type of process. And now we are like independent process and the cooperative process. Like main reason the main function and main definition of the process synchronization is way to coordinate between the two processes which share the same memory. Okay, to like maintain the data consistency, all this thing. So what is the IPC? So like IPC, as we discussed earlier, that the thing IPC. So inter-process communication, and it is a mechanism that required to use the resources like memory that is shared between memory and thread. So inter-process communication. This is the process one, okay, and this is the process two. And that mechanism that required to like use the resources of other mechanisms. So like if we know that the pipe is used for the communication between different process, and inter-process communication required to use the resources of this resources and memory from different process and the thread. And IPC, with the IPC, OS allow different process to communicate with each other. So if we use the resources and memory of this like process, so first of all we have to like establish the communication between this thing. So this allow the operating system to communicate with different operating system, a different process, and it is simply used for the exchanging the data between multiple thread in one or more program or the process. In this mechanism, different process can communicate with each other. So in this mechanism, the different process can communicate with each other with the approval of the operating system. Okay, understand IPC? So like inter-process communication is a mechanism that require to use the like memory and the resources from the like shared like use the memory like resource like memory that is shared between the process or threads. So with IPC allowed the different process to communicate with each other, and it is a like simply used for exchanging the data between threads or like program or process. Okay, all this thing. So in this mechanism, different process can communicate with each other with the approval of OS. So what is pipe? What is like IPC mechanism? So that is first of all we establish the pipe, then we use message queue. Okay, then message queues and semaphore. We have like different requests. So like semaphore and the the communication between software and hardware, all this thing happen. Then we have shared memory, and then we give the signal. So like pipe communication style, like in a message queue you put our one request inside and another request inside, and the first request is like send and shared memory, and then we get a signal that we receive that memory. Okay. So what is it different? What is different main memory and secondary? What is difference? What is different between like main memory and secondary memory? We all know that main memory. So main memory, we can say that the main memory in a computer is RAM, random access memory, and it is also known as primary memory only for read, write, or the internal memory. And the program and the data that CPU required during the execution of the program are stored in the memory. The main memory is known as the main memory in a computer is also known as the primary memory or the read write memory in an internal memory, and the program and the data the CPU required during the execution of the program that are stored in memory. Okay. So what is secondary memory? So secondary memory in a computer are the storage device, okay, that can be stored data and program. So like secondary memory is like a storage device. They store data and device, like program. So it is also known as the external memory or additional memory for the backup memory or the auxiliary memory. So such storage devices are capable of storing high volume data. Okay, such devices are like capable of storing the high volume data, and the storage device that can be hard disk, USB, CDs, all these things. So like, let's see the difference between main memory and the like secondary memory. Like data can be so in primary memory data can be directly accessed by processing unit, and in this like secondary memory, the firstly data is transferred to the primary memory and then after it routed to the processing unit. So like it takes two steps. So it is volatile and non-volatile in the nature. It can be both volatile and non-volatile in the nature, but secondary memory is in like definitely are non-volatile. Let we after switching off the computer, like the memory or data that remains intact in that memory. It is more costlier than secondary memory. It is cost effective and less costly than the primary memory. And it is temporary because the data is stored for the temporary, and it is a permanent because that data is stored permanently. In this memory, the data can be lost whenever the power failure occur, and in this memory, data is permanently stored and therefore cannot lost even the case of the power failure. So it is much faster. It is much faster memory and serve like save data that is concurrent and used by the computer. It is slow as compared to primary memory and like save the different kind of data in a different format. So it can access by the data and it can be accessed by the input output channel. So these are the primary difference between primary and the secondary memory. So what do you mean by the overlay in operating system? So overlay, so like stand for overlay. So overlay is basically a programming method that divide the process into pieces. So overlay, this is the process. We divide into the pieces so that the instruction that are important and need to save the need and can be saved memory. Okay. So it does not need any type of support from the operating system. So overlay is like a programming method in which we divide the processes into the pieces so that the instructions that are important and need and can be saved into the memories. Okay. So it does not need any type of support from the operating system. So it can run the program that are bigger in the size. This is the program that is bigger in the size, and this is the process, and in that this is more important. So in that case we can like converted like divided into pieces, and this is the important task we like need and we save in our memory. So it can run a program that are bigger in size and then the physical memory, and keeping only the important data and instruction that can be needed at a given time. Okay. And so next thing is that write top 10 example of the operating system. So top 10 example. So we know that we are using the MS Windows, Microsoft Windows, then Ubuntu, Linux based one, Mac OS, Fedora is also Linux based, Solaris is also Linux based, PBDS, Chrome.os, CentOS, Debian, and Android. So these are the different operating systems that are used by different community. Now move to another question. What is a time sharing and how does it help user? The time sharing is a technique where the CPU switches rapidly between multiple processes. Okay, this process using this process have a black theme, dark theme. So okay, and this theme has a light theme. Okay, this process have the light theme. So how can we say that how can time sharing work? So in that case, CPU switch rapidly between the multiple giving the such process a time slice. Okay, so this work for the 3 millisecond. This also work for 3 milliseconds. So we can see the blinking effect. So time sharing technique where the CPU switches rapidly between multiple process, giving each process a small time slices. Okay. So this create an illusion that multiple programs are running at the same time. Okay. So in that case, we are thinking that multiple programs are running at the same time. The time sharing provide a system responsive and allow multiple user or the application share the system resources efficiently. One second. So it is especially used in the multi-user and multitasking operating system. So when you are you are using the time sharing system. So we understand that the time sharing system is a mechanism through which a CPU switches rapidly between one process to another process and giving a process a small time slices. This created an illusion that are running at the same time. This improved the system performance, efficiency, and responsiveness, and it is especially useful in the multi-user and the multitasking operating system. Let's talk about latency and let's talk about the latency and why does it matter in operating system. So latency is like one of the most important things. So latency refer to time taken to respond to a request or the event. So if this process request this thing to another process, and in how much time is taken to provide that the response. So this is called latency. Okay, time taken to respond to a request or an event is known as the latency. So in an operating system, lower latency means faster responses to the user action, interrupt, or system call. And higher latency mean that higher latency can make a system feel slow and unresponsive even if overall throughput is high. Okay, throughput. Understand last time. Throughput is how much packet we can send. Okay. So it is especially important in the real time and the interactive system. So when we are using a real time operating system, in that we want lower latency. So what is context switching? So what is the context switching? So context switching is a process of saving the state. So context switching is a process of saving the state for the one saving state of the one process and loading the state of another process so that CPU can switch between them. So this process is working. So this is the ready queue and another process is coming. So first of all, what operating system do? So it save the data or state from this process and load this into the memory. Okay, in a CPU. Okay. So when operating system switch tasks, so it store the information like register, program counters of a current process, like what states they stored, like a register, program counter of the current process, and restore the save state for the next process. So this allow to process the share this allow multiple process to share the CPU efficiently. Okay. And another thing, what is the difference between interrupt difference between interrupt a trap, and an exception. Okay. So these terms describe the different way to control and transfer the operating system. First of all, the interrupt is like it is triggered by the hardware or the external event, such as such as input output completion or the timer signal. So it is asynchronous to currently running process. So like any other like issue occur in the hardware, so it triggered interrupt signal. Okay. Trap is a deliberative synchronous event caused by the program, commonly used to invoke a system call. So trap is a signal that are sent for caused by the program, and it is used for to invoke the system call. Exception is occur due to the error during program execution, like when we are dividing something by zero or like accessing the invalid memory. Okay, these are the things. What is the difference between system call and the library call? So system call is a request made for the program system call is a request made by program to the operating system kernel to perform request made by the program. So it is made by program to operating system to perform privilege operations such as reading the file and creating the file. So in that is known as a system call. Okay. Like it is a request made by program to operating system kernel to perform a privilege operation that are like reading the file, creating the file, all these things. Whereas the library call is a function that provided by the programming library that run in a user space, and it may perform computation. So it may perform computation on its own internally invoke system call. So programming. So what we call it? Library call is a function provided by the programming library that run in a user space. So it may perform computation so it own or like internally invoke the system call if a kernel access is required. Okay. Let's understand what is system call and why we need it. The system call is a mechanism that allow a program running in a user mode to request a services from the kernel. Okay. System call is a mechanism in which a program is running in the a user mode can request services from the kernel, and the operation like file access, process creation, memory allocation require kernel level permission. Since user program cannot access this, since user program cannot directly access these resources, so they use a system call to safely communicate with the operating system. So what we call for the system call? The system call is a mechanism in which that allows the program that is running in the user mode can request services from the kernel. So file access, file creation, memory allocation. So these are the kernel level permission that requires. So because the user program cannot directly access all these resources, that's why they use system call that safely can communicate with the operating system. System call help to maintain the control, security and the proper resource management in the system. Okay. Now we have to understand. We talk about what is the user mode and the kernel mode. Okay. So let's see what is in operating system work. Operating system work in a two mode that maintain the security and the stability. First thing is that user mode. So is a normal application. User mode is where the normal application run. Okay. And in this mode, program have the limited access to the system resources and cannot directly interact with the hardware. Okay. So user mode is a normal application where it's run, and it is a mode where program have a limited access to our system resources and cannot directly access the hardware. But when the kernel mode is where the operating system core run and it have a full access to the hardware, memory and all the system resources. So it depends on in which mode this your program is running. So these category ensure that the application, if the application crash or misbehave in user mode, it does not affect the system entirely. Okay. Different type of this is an intermediate question, so different type of this thing we have to study in the next lecture. Okay, what is zombie process? What do you mean by cascading, starvation, aging? Okay, new state running, different type of process state, new state running state, waiting state, all these things. What is first come first serve? What is thread in operating system, virtual memory, round robin, before memory process, context switch, and the thread context switch, preemptive, non-preemptive. And in the first lecture, I think that we have studied all the fixed block. What do you mean fixed block? Like page size, fixed block in virtual memory, and in the frame size in the what covered the where the multiple process initiate and save the same memory and copy created. Okay, what is the internal external fragmentation? Like when so what do you mean internal external fragmentation? So in which memory allocated larger than internal mean that internal mean when a memory free split in a smaller non-continuous block. Okay, priority inversion mean that occur when a higher priority is given to the higher priority, higher priority process is forced to wait and the lower priority has to be work. Okay, producer and consumer problem is that is a classical synchronization problem. Like producer consume data and place into this producer produce the data and place into the buffer, and consumer remove the data from the buffer. So the challenge is that the producer sometimes add one data whenever the buffer is full, and consumer can extend data. So in this is a common problem synchronization techniques. So that's why you use semaphore and mutex. So monitoring, like how we monitor the operating system. So in that case, we know that one is mutual exclusion, another conditional one. Okay. So the difference between mutex, so you have mutex a lock-in mechanism to ensure that mutual exclusion. Now only one can process the critical section at a time. So typically own and release the same thread, and semaphore is a signaling mechanism that control resources using counter all this thing. What is kernel? We understand control basically the central component and the module of the operating system that handle, manage, control all the operation, all this thing. And so what are the functions? So we understand that it manage all the component sources, facilitate all, initiate the interaction between these things. It manage the RAM so that all memories can work efficiently, control all the primary actions. Semaphore is a signal mechanism or synchronization mechanism that used to control the shared resources, multi-thread and multi-programs, and it can be available resources that provide two atomic operation, that is wait and signal. So it can count greater than one, all this thing. Binary semaphore, then this thing. So we understand what is the mutex. Okay, so it is based on locking mechanism. So mutex is slower than binary, all this thing. It basically an object that can hold lock that information. So different type, monolithic and microlithic, hybrid, nano, exo. So mono versus micro. So micro is a minimal operating that execute only the important function operating system that only contain near minimum number of features that function the required to implement the operating system. So this is microlithic, and monolithic is so it is a OS architecture that support all the basic information of the computer, such as resource, all this thing. So mono in that micro in which system program kernel services present, all the services that are present. So it's smaller in size as compared to monolithic. It is larger as compared to time sharing, context switching. We understand the context switching, different type, kernel versus OS, process versus thread. Okay, various type of memory, all this thing, deadlock. We understand the deadlock, mutual exclusion, and validity. Okay, spooling is the spontaneous peripheral operation online. So it is like putting the data in various input in the buffer. Okay, and the buffer means a space area with the disk that can be accessed. So it is used for the mediation between the computer application and so the peripheral things. Okay, so hard links, soft links. So okay, that's all for this session. Now we will see all this thing and revise in tomorrow everything. Okay.